Hello everyone, this is Mark Fennell again, and I am going to talk to you today about the nature of the atom, the next in my series on the nature of the atom. Today I'm going to talk to you about stable versus unstable orbits. Now, this is something you think about. Bohr came up with the idea of unstable orbits, and it's been taught in schools. But what does that really mean? Okay. It's not the orbits themselves that are unstable. It's that the electrons change their energy. Okay. Bohr came up with the idea that electrons can exist only in certain orbits. And as we described in a previous video, those orbits exist, those distances exist, because that's where the lengths of the gravity strings extend to. So there can be nothing in between. The orbit will not travel anywhere in between the lengths of the gravity strings. Only where the gravity strings end, which are here and here and here and here. But stable versus unstable. It's really about the energy of the electron. Because all orbits are stable. Because all gravity strings are stable. Right? The lengths of the gravity strings are what they are, and they never change. Those are fixed. Those are permanent. Those don't change. For a particular size nucleus, whether you're talking hydrogen or uranium, the lengths of the gravity strings are what they are. Those don't change. And we can add or subtract electrons. We can add photons to those electrons, bounce them up and down. But the gravity strings won't change. The possible orbits won't change. Those are fixed. This also means that any electron will orbit at its distance forever. Forever and ever and ever. It is in fact a stable orbit. And we know this because most atoms, it's only with photon absorption that they move up and down. The rest of the time, those electrons are stable in their orbits. So we have electrons that are stable in their orbits, let's say level 3. Then a photon is absorbed here, and this electron level 2 jumps up to level 3. What's the difference? Level 3 is still a good orbit. It's still a stable orbit. It's still the level where the gravity string ends. The electron will continue to spin in that orbit forever if its energy didn't change. So it would, in fact, stay there forever. The only reason it doesn't is because it has the capacity to lose energy. And it has the capacity to lose energy because it has a photon core. And how to get the photon core? Because it absorbed the photon core to begin with. That's the difference between this electron that jumped up versus all the electrons that are already there. Okay? The other electrons that are already there don't have the photon core in them, and so they're not emitting. They don't have the photon core, so they can't emit a photon. So they won't lose energy. They'll just stay and stay and stay and stay. But the electron that has absorbed a photon core bumps up, energy gets rearranged, the photon core leaves. Now, what's left with the electron? A lot of the energy that was added was now taken away. It's usually not the same. They can be the same, usually a bit less. And so the electron, having less energy, will drop back down. So the orbits are stable only until you change the energy. The energy will change in that way only through photon absorption and then emission. Electrons that are already there, they don't have the photons in them. Therefore, they're just fine where they're at. and they won't drop down. So there you go. All orbits are stable unless you change the energy. And you change the energy through photon absorption and emission. And that is my lesson for today.